Okay, so yeah, so we want to find the solution set to this equation. Let me switch to a different color. Here we go. All right, so we rewrite. We notice that the x squared and z squared, or x and z appear only as part of that form. So let me rewrite this as x squared plus z squared minus y squared is equal to 1. So this is rotationally symmetric. Around the y-axis. All right, now I always have to think these through. I have to draw myself a little picture, if only in my mind, but I think it's really convenient. If something is rotationally symmetric around the y-axis, here's the y-axis. I can understand that as being a rotation of something in a half plane, and I can choose, for example, that half plane. Or I could choose this half plane. Suit yourself. It doesn't matter which half plane you pick. Right? A lot of students tend to prefer the xy half plane because x is alphabetically earlier than z, and it's therefore a little bit less scary. Right? I would encourage that we do the yz, the positive part, the z positive part of the yz plane. The reason why is this is what I'm going to call looking straight at us. There's no perspective drawing inside of that half plane. And things are always a little weird to draw laying down like that in the xy plane. So it's actually easier to use this one. Is that cool with everybody?
Yes.
Okay. All right, now algebraically, how do we describe this half plane? Well, that's where x is equal to 0. And, well, I need z to be greater than equal to 0. Okay, so I'm going to take this, put it into there, and see what happens, right? And what I get is that in the half plane, whoops, I get, well, let's see, x is equal to 0. Okay, so that goes away. Z is positive, whatever, but I end up with z squared minus y squared is equal to 1. So now the question is, we know that's a hyperbola. Which way does it go? Right? It is easy to get that confused. Again, I have to sort of, I have to think it through each time. If I were to say, let's let y equal 0, and that goes away, cool, no problem. Y can equal to 0, right? And you get z equal to plus and minus 1. And that's fine, right? But if you were to try to set z equal to 0, oh no, swing and a miss. So z cannot be 0. So we're talking about a hyperbola that doesn't come anywhere near the y-axis, and yet goes through those 2 points, right? And so now you see which way it goes, and so that means it's like this and like that. Okay, so that's what that looks like, but of course now we're only interested in the part in the half plane, specifically that half plane where z is positive, and that means I'm only interested in that part of the curve. Right? I am not interested in this part of the curve. That's where z is negative, no fair. Now, of course, it doesn't matter. We don't need that part of the curve either. So we have no use for it, but it is algebraically problematic in general.
Right.
Okay. Alrighty. So the curve then is a hyperbola, half of a hyperbola up there like that. The curve is rotationally symmetric around the y-axis, so I take that curve, rotate it around the y-axis, and the result. Now again, there's a drawing of what you get in the book. It's just a drawing. I think it's turned in a different direction, but it's morally the same thing. And so you can kind of cheat by copying from the book. And it's something that's kind of like that.
Yes, definitely.
Yeah. Everybody happy?
Yeah.
Okay.
And that's the one-sheet hyperbola?
This is a hyperboloid.
Hyperboloid, that's right, with one sheet.
Hyperboloid of one sheet. If you say with, yeah, sure. I mean, the grammar is not critical. Yeah.
Yeah.
Okay.